Buckle up, space explorers, because we're blasting off to the fringes of our solar system on a daring mission to meet two enigmatic dwarf planets, Eris and Makemake. Forget everything you thought you knew about these distant ice worlds, because recent discoveries are rewriting the script. Imagine dwarf planets with hidden oceans, volcanic eruptions spewing icy geysers, and surfaces as colorful as a cosmic fruit salad. Are you ready to ditch Pluto and explore the hottest newcomers in the celestial neighborhood? Then dive in, because this journey promises to be out of this world. Does the mystery of the cosmos not stir your soul, particularly as we ponder the potential of life on other planets? The universe, in its vast expanse, teems with celestial bodies, each harboring secrets in their icy craters and rocky terrains. Today, our focus hones in on two such enigmas, Eris and Makemake, the dwarf planets nestled in the enigmatic Kuiper Belt. Dwarf planets, once considered cold and lifeless, have emerged as subjects of fascinating study. The spectral observations of methane on Eris and Makemake have challenged this perception, revealing an intriguing possibility that these distant worlds are geologically active. This discovery, sparking a paradigm shift, compels us to reevaluate our understanding of outer worlds. The D/H ratio of methane on these celestial bodies points to intense geological processes beneath their icy surfaces. This finding, while intriguing, is not an isolated revelation. It suggests a larger narrative, one that paints a dynamic picture of the Kuiper Belt, a region once thought to be static and unchanging. The presence of methane on both Eris and Makemake is intriguing. This gas, often associated with life on Earth, hints at the possibility of hidden oceans beneath their icy surfaces. Could these distant worlds harbor unknown forms of life, adapted to the frigid depths? It's a tantalizing question that future exploration might answer. The James Webb Space Telescope, an instrument of unprecedented precision, has offered further insights into these dwarf planets. Spectral data suggests that Eris and Makemake may harbor warm, watery interiors, capable of sustaining oceans of liquid water. The methane on their surfaces, believed to be a product of hydrothermal reactions deep within their cores, hints at geothermal activity. The isotopic ratios of hydrogen and carbon in the methane provide compelling evidence of a geochemical origin. This information, rather than suggesting accretion from the primordial planet-forming disk, points to the possibility of cryovolcanism. Such a process, where water, ammonia, or methane replaces molten rock, could have resulted in the outgassing of methane onto the surface of these planets. The implications of these findings are profound. The presence of subsurface oceans and the potential for geothermal activity open up new avenues for research on planetary habitability. The models developed for these dwarf planets could also apply to Saturn's moon, Titan, and may impact our understanding of its presumed habitability. While colonizing Eris and Makemake might seem like science fiction, it sparks the imagination. The vast distances, extreme temperatures, and lack of resources pose immense challenges. But who knows what technological advancements the future holds? Perhaps one day, humans will set foot on these distant worlds, not as conquerors, but as curious explorers seeking to understand their place in the universe. While both Eris and Makemake are classified as dwarf planets, they pack a punch in the size department. Eris is slightly larger than Pluto, while Makemake comes in third. Think Earth's moon? Tiny in comparison. Eris is about 1,163 times larger, and Makemake a whopping 874 times bigger than the moon. But compared to Earth, they're still pint-sized. Eris is roughly 6.7 times smaller than our planet, and Makemake about 7.4 times smaller. The revelations about Eris and Makemake underscore the significance of further exploration of the Kuiper Belt. This donut-shaped region of our solar system, home to icy worlds like Pluto, is increasingly seen as a dynamic region, teeming with potential for new discoveries. Here are 8 intriguing facts about Eris and Makemake. Size surprise. Despite being called dwarf planets, Eris and Makemake are no slouches. Eris is slightly larger than Pluto, while Makemake ranks third among Kuiper Belt objects. Both dwarf planets dwarf Earth's moon, being hundreds of times larger. Icy rainbow. Their cold surfaces aren't just white and boring. Eris boasts a reddish hue due to nitrogen ice, while Makemake shines with a pinkish glow thanks to methane ice, creating a cosmic color palette. Moonstruck Makemake. Unlike Eris, Makemake has a unique companion, a moon named S2015, 1364721, nicknamed MK2 for short. This tiny moon is only about 160 kilometers across, yet it orbits Makemake in perfect synchrony, presenting the same face all the time. Hidden oceans. Both dwarf planets could harbor internal oceans beneath their icy shells. Evidence comes from the presence of methane, often associated with liquid water on Earth. Could these oceans hold the key to unlocking life beyond our planet? Cryovolcanic whispers. Recent findings using the James Webb Space Telescope suggest potential internal activity on both Eris and Makemake. Could they be spewing icy geysers like cryovolcanoes? This hints at more dynamic and interesting worlds than previously thought. Faster than you think, Makemake takes the prize for the fastest rotation among dwarf planets, spinning on its axis every 22 hours. This rapid spin even gives it a slightly flattened shape at the poles, like a cosmic spinning top. A billion miles apart, despite their close proximity in the Kuiper Belt, Eris and Makemake are actually quite far apart, over 1 billion miles. Traveling between them at the speed of light would take about 5 hours. Future frontiers. Studying these distant dwarf planets helps us understand the early formation of our solar system and the potential for life in extreme environments. They might be far away, but they hold clues to our cosmic past and future. Before we go, here are some other planets and moons with the potential to support human life. Kepler 186f. This Earth-sized exoplanet orbits a red dwarf star in the habitable zone, meaning it could have liquid water on its surface. While the star's radiation might require shielding, the planet's size and potential water make it a prime candidate. Proxima Centauri b. This rocky exoplanet is the closest to Earth at only 4.2 light-years away. It orbits a red dwarf star, but its potential for a habitable zone and Earth-like gravity make it intriguing. TRAPPIST-1 system. This system boasts 7 Earth-sized planets orbiting a small, cool star. Some planets might be tidally locked, but others could have habitable zones with liquid water. Further study is needed, but the sheer number of potential planets makes it exciting. Europa, Jupiter's moon. This icy moon harbors a vast internal ocean, potentially warmer than Earth's surface. While the surface is frigid, the ocean could support life in hydrothermal vents. Technological advancements might allow us to access this watery world. Enceladus, Saturn's moon. Similar to Europa, Enceladus has a subsurface ocean and spews water vapor geysers into space. The geysers could be sampled for signs of life, and the ocean's potential habitability makes it a target for future exploration. Titan, Saturn's moon. This moon has a thick nitrogen atmosphere and liquid methane lakes on its surface. While not ideal for human life as we know it, Titan's unique environment could harbor exotic life forms adapted to its conditions. It's a valuable laboratory for studying life in extreme environments. In the grand tapestry of the cosmos, Eris and Makemake are but 2 threads, yet their story has the power to alter our understanding of the universe. As we continue to gaze into the celestial abyss, we are reminded that the universe, in its silent majesty, is constantly whispering its secrets. The question is, are we listening? Thanks for joining us. Do like this video and subscribe to Sci Sips.